Good morning, everybody. Welcome to class this morning. Another week, another new module, right? So we're starting to progress and advance, right? Into now we're actually going to start making some stuff, which is pretty cool. As we start module 4 today, we'll be looking at programming. We'll be looking at the same basic data structures that we looked at in our programmatic thinking module with our block logic. Things like variables and loops and conditionals. You know, we're continuing with these same basic structures, and we'll be doing them in Python now, and we'll be doing them later on in JavaScript, in PHP, in other programming languages as we are working through the idea of programming and how we make all this work. But before we get started today, just a couple of announcements. One, right off the top, and it is a pretty big one. There will be no regular live stream next week. Right here at Cleveland Community College, next week is fall break. Or at least most of the week next week is fall break. So we will not be having our regular live stream next Monday. I may post a video that's pre-recorded that we could use in its stead. But we'll see how all that goes. We'll see how much we get through today as to whether or not we need to do that for next week as well. We got a lot to cover today, so we're going to try to cover it all. But there might be a little something that we want to do in a pre-recorded video for next time. Also, it's a good time to talk about how the fact that this module is a 2-week module. So your assignments for this module aren't due this coming Sunday. They're due the following Sunday. So you have 2 weeks to complete the assignments for this module. If you want to go ahead and get them knocked out early and take the next week off to kind of enjoy your fall break, that's up to you. Yeah, I kind of wanted to give you all the option of being able to take the fall break off if you wanted to. Normally this is a 2-week module, but with it falling around right this time with fall break here, in order to be able to kind of accommodate you for a bit of a break and still, keep the course on track to get us to where we need to be at the end of the semester. This is what we had to do. So it's, it is what it is, right? Let me see here. Are there any other announcements, any other big things that I need to cover? Yes. One more thing, right? And it's something that I'm going to remind you of now, and you'll want to hear about it again as it actually gets a date scheduled for it, and as we get closer to time. Right? It's around this time every year, around the 2nd or 3rd week of October, that we get our spring schedules kind of put together for what classes we'll be offering in the spring. And one of the things that you'll want to do is kind of keep your eye out for our advising day. Every fall we do an advising day where we have all of the IT students kind of come through. We have a look at where you're at in the program, what you need to be taking in the spring and all that sort of stuff. And it's especially good for you all who are in the foundations courses as you're getting those completed this semester. For those of you, especially for those of you who are continuing with, an IT degree or diploma there, that we want to make sure that you're staying on track, that you're doing the right things, that you're taking the right courses, and getting what you need. So, keep your eyes peeled for that. We'll be getting a date finalized for that very soon. And we'll be posting announcements and things about it for it as soon as we do that. But I just want to make you all aware of the fact that that is something that we do. And it's about that time, so start keeping your eyes peeled for that. It's super important. I think that is all the announcements that we have for today. So we need to go ahead and get into what we need to talk about for Module 4, which we're talking about actually starting to program, right? Like we've laid this foundation here. Right, we kind of looked at the history of everything to kind of give us a baseline understanding on where things started and how it got to where we are now. We looked at how the internet works so we can understand like how the different platforms that we are coding on, whether it is software development or web development, how these things kind of work in terms of sending and requesting information. And then last week, we looked at our programmatic thinking module to kind of get ourselves in the mindset to begin writing code. Right? We learned about a few basic data structures using block logic. You all went through the hour of code stuff as your big lab for last week, which really got you using those blocks and figuring things out that way so you could see the visual connections between different things in code. And get an understanding of kind of how all this works. We also talked about a frame of mind that we need to be in as we are approaching learning how to program. And I want you all to remember that as we are doing this, because it is super critical and super important. It's a whole different way of thinking. So as we start out today, what I'd like to kind of do is I'd like to just review a few concepts, talk about a few vocabulary terms that we'll need, and then we'll get into using Python and starting to write code in Python. And I think what we'll try to do is we'll try to get through as much of this content as possible. And then for the pre-recorded video that you will get either later in the week or early next week, at our normal live stream time, I'd like to kind of sit down and write a program from beginning to end, kind of demonstrating all of this to you all. So we'll kind of look at how all this works in isolation, and then we'll take it all and put it together in a program. Which, speaking of program, just what exactly is a program? Right, so one of the things that we've said now, and we kind of, tie a line through all of these modules that we've done up until this point, one of the things that we've said now is that our computers are dumb, right? Our computers are not smart. We as human beings are smart. And as smart human beings, we need to be able to give our computer instructions in order to tell it what to do. So this sequence of instructions that tell our computer what to do is a program, right? So we have this definition here that a program is just a sequence of instructions that specifies how to perform a computation. And remember, when we're talking about computations in this sense, just like we talked about way back when, right? We could be talking about a mathematical computation, right? Doing simple math equations. Or we could be talking about symbolic computations where we're using, letters and symbols and stuff to do various odds and ends. So it's super important that we kind of have this understanding of what a computation is. When we're talking about this frame of mind where we're talking about a computation. Because when we look at like websites and things, right? Like we look at websites and they have pictures and videos and all this, going on them. And it takes a computation to be able to show all of that, to be able to get all that information to you. But at the same time, right, when we're talking about computation here, it's not math. We normally think about computation in terms of math. And really, if we kind of break it down like it all is math, like we talked about that before, right? Like it all just kind of breaks down into binary zeros and ones and, all that kind of fun stuff. But, we want to make a distinction between these two different types of computations for these purposes. So we say a program is a sequence of instructions. So what exactly then is a construction? What exactly is an instruction? And for our purposes, an instruction is just a line of code. So, right, we can think about it in terms of the algorithms that you did last week, right? When we're building these algorithms the way you all did last week, when you built the discussion board algorithm, where you took an ordinary everyday task and you broke it down into a sequence of steps that you could give to somebody who just came, who understands English, but they just came down to the planet for the first time. And they could take that task and they could perform it, right? And each of those things that you did was an instruction. It was a singular line that gave out a step, right? And when we're talking about instructions for our programming purposes, we're talking about a singular line of code that is a part of our algorithm, that is a part of our program, right? So we can take and we can relate those algorithms that you wrote last week to the algorithms that we're creating for our computer, because that's essentially all we're doing is we're creating a series of instructions step by step that tells our computer how to solve the problem. Our computer is like that idea of the alien or the person that we talked about last week that just came down to Earth, and they know what this means, but they don't necessarily know how to perform the task. Now, when we're looking at these instructions, one thing that we'll see, and one thing that we saw, when we were looking at the history of programming back in Module 1, right, when we looked at all those different programming languages and all those hello worlds and the different programming languages, they looked very, very different. They looked very, very different. But there are certain things that are consistent in every single programming language. And we see a list of those things here. They are input, being able to get data from a user, whether it's from a keyboard or from a file or from the network or some other device. We want to be able to get data somehow, right? Because remember when we talked about our data cycle, right? We take data, we process it, we turn it into information. If we're going to be processing something into information, we have to be able to get the data that we need to process. So we have to have an input. Outputs. This is basic data that just displays on the screen. Right? And so we're going to save it in a file, or we're going to send it over a network, or we're going to show it on a screen, and this is the output. So this is getting that processed information out of our computer. Right? We need to have a way to get data into our computer, and we need to have a way to get processed information out of that computer through our output. Right? Because if we process that data into something valuable, like information, we need to be able to access that value. Math. We've got to be able to do math. We've got to be able to perform basic mathematical operations. Addition, multiplication, subtraction, division. One of the things that we'll talk about exponential notation. And we'll even introduce you to a brand new operator that you've never heard before called the modulo. That's super cool. Right? Another thing we want to do is we want to have conditional execution. Remember conditionals from last week. If something is true, we want to do something else. Right? So if whatever, something happens. So we're going to be able to check for conditions, and we're going to be able to run the appropriate code. And finally, repetition. We want to be able to perform some action repeatedly, usually with some variation. And we're doing this for our purposes to get started with loops. For those of you who are in the programming and web development program, one of the things that we will talk about is another way to do this that is more of a higher level way to do this that we call recursion. But for our purposes right now, since we're just getting started, since this is all brand new, we're going to be using loops to perform this action. And so these 5 things here, input, output, math, conditional execution, and repetition, These allow any programming language to be Turing complete. So when you consider a programming language and you consider it to be Turing complete, it has to have these 5 things, which is why when we get into the next module, module 5, in a couple weeks and start talking about HTML, we'll say HTML is not a programming language because it's not Turing complete. It doesn't have these things, right? HTML can't do math. HTML can't check for conditions. HTML can't loop, right? But what we're using right now with our first programming language that we'll be working through is Turing complete. It has all of these things, and we'll be covering how to do all of these things. And it is Python. So Python is a language that was created by Dutch programmer Guido van Rossum. And if you'll remember back, that I believe he was one of your figures that you could choose for your Module 1 essay lab. And we say this is a high-level programming language. Right? And remember, like last time, we defined what makes a programming language high level. We said for a programming language to be high level, it needs to be close to English, right? It needs to be, or really any spoken language for that matter, right? Like it needs to be something that we could interpret as human beings, or something that is easier for us to interpret as human beings than it would be for our computers to do it, right? Makes our lives easier. That's why we take and we run all of our programs through an interpreter. So the interpreter can take the high-level programming language that we're writing in and interpret it to our computers in something that it understands. Python is open source and community driven, which is a big deal, right? It means, when something's open source, typically that means it's going to be more secure in general, right? Like one of the things there has to do with the security of the software because it is open source. So everybody in the world can see it. There's full transparency as to what is in the code base, what's in there making things work, all that sort of stuff. Right, so it's a little harder to sneak some things in there that might not be so great. It's also community driven, which means that there are a ton of dedicated people working on the code base, making things better, making this as easy as possible for us to get started in programming. And we say that this is also a batteries included programming language, which means that there are a bunch of modules that are included with the language, right? Which is pretty typical for modern programming languages. On top of the base language, you include a bunch of other modules that do things for you that you typically do a lot, right? We write these other functions to help us perform tasks quickly and easily. Since Python is community driven, you have a bunch of programmers. All programmers want to do is kind of get lazier and lazier, right? So we're going to automate solutions for ourselves. So if we find ourselves writing the same code over and over and over again, we're going to take that code, we're going to modularize it, and we're going to put it into one of these already included modules in Python, right? Because at the end of the day, that's what you want. You want your life to be easy. It's technology, right? Another thing is that Python is dynamically typed, and that doesn't mean a whole lot to you at this point, and it won't really mean a whole lot to you over this class, right? I think pretty much everything that we're doing is dynamically typed. When we're talking about typing, it becomes a whole lot more critical when we're working in something like Java, right? Java is not dynamically typed. But one of the things that we'll talk about in just a little bit are the different data types, things like integers and strings and floats. Right, and having all of these different integers, or having all these different data types, rather, provide us the ability to do different calculations in our program. And they give us different outputs. And in some programming languages, like Java, if we're working with an integer, we need to tell our programming language, this is an integer that we'll be working with. In Python, we don't have to do that. Python just gets it, right? Like Python, you put in a number, it says, oh, that's an integer, there's no decimal point there, we're good, let's go. So why exactly? Why Python? It's one of the most widely used programming languages in the world. Right? In recent surveys of programming language use, currently the top 3 programming languages that are used in the world in no particular order are Java, Python, and JavaScript. Which is why the 3 primary programming languages that we cover in the programming and web development program here at Cleveland Community College are Python, Java, and JavaScript. They're the 3 most widely used programming languages in the world, and Python in particular has been a tried and true language that's been in development since 1991. And a lot of people don't realize this, just because, you only really started hearing a lot about Python more recently, like within the last 10, 15 years or so. You started to hear a lot more about Python, but Python's been around for 30 years at this point. And that's actually, and a lot of people don't know this either, that's actually around the same time when Java was being developed. A lot of people think Java's older than that. Java was just being developed in the early 90s, like around 91. And then around like 92, and then around like 95, we got JavaScript, right? After the boom of the internet. So Python came around 1991. It's 30 years old now. And in fact, I think it was just Python Day recently, like within the last few weeks here. So it recently just had its 30th birthday. And it's easy to get started with, and you'll see that as we kind of work in it. A lot of people, when they're starting to teach code like this, traditionally, right, because it was one of the ways that I started learning how to code when I was in college, is they'll start you out by using what we call a teaching language. And teaching languages have no other real purpose. They're not used in the real world. They have no other real purpose than teaching you how to program. And I said, that's what I did when I was in undergrad at the University of North Carolina. My very first classes in which I did programming, we used a programming language called Turing. And Turing is not used in the real world. It's one of those teaching languages. From there, of course, we did, Java and C++ and C and all this other kind of stuff. That's, real high-level programming. But to get started, to kind of dip our toes in the water, we started with a teaching language. But Python's a good language for teaching, because it takes things and simplifies them and makes them easy to read. It's really easy to get started with, but it's not a teaching language. Right? We said, just a few minutes ago, right? Like Python's one of the number 1 programming, it's one of the top 3 programming languages in the entire world. So it's not only easy for us to kind of wrap our heads around and start to use, but it's also something that we can actually take skills from learning it and apply them in the real world. It's actually being used in industry. It's being used to develop scripts for data analytics. It's being used to develop software. It's being used in web development. There's all sorts of different applications for Python. And it's easy to learn, like it's easy to use as a teaching language, because the syntax isn't as complicated, right? Like we mentioned before, when we talked about syntax is essentially the way we write something. Right, when you think about it in terms of English language, You think about it in terms of like, oh, where am I going to put my comma? Where am I going to put my period? Where am I going to put my question mark? Should the subject and verb, like subject-verb agreement, all that kind of stuff. Right? That's what we're talking about when we're talking about syntax. And when you get into a lot of programming languages, you see a lot of curly braces and parentheses and semicolons that we have to place in various places. In Python, we don't have to worry about that. There is one thing that we do have to worry about, which is indentation. But we'll talk about that as we get there. And just a little fun fact for you, it is called Python because of the television series Monty Python's Flying Circus, one of Guido van Rossum's favorite television shows, which he shares that with a lot of people. I think Monty Python had a big influence on a lot of people. So for simplicity's sake, we'll be using an online IDE. An IDE stands for Integrated Development Environment. And this is replit.com or repel.com. Or replit.com or repel.it. Right, the link to that, if you have forgotten, is back in your Begin Here module if you need to go back and get that. Or you can go to repel.it, like you see listed on the slide here, or replit.com. All of those things will get you to the same place. Now, if you want to try it out, you can try out the Python IDE, which is called Python Idle. In order to do that, you'd go to the Python website, you'd download their installation package, install all that on your computer. That's a little much, especially since some of you will probably never be writing any of this ever again. But if you want to give that a try, you're welcome to seek that out and do that. But for our purposes, we'll be using Python 3. And Python 3 is like the big thing, right? Like there was a Python 2. Python 2 has been sundowned. Like it's not really being maintained and updated anymore. Like you still might find some legacy versions out in the wild. But Python 3 is where it's at and where it's probably going to be for a while. I think they seem more focused on updating the current code base than instead of trying to create a new code base like a Python 4, which is smart. But let's go ahead and open up. Let's go to that website that we talked about there, that repel.it, replit.com. I already have it pulled up in a window here. Let me just find my window. Too many windows. Here we go. So when you get to this site, again, we can see up here replit.com, repel.it, or the link in the Begin Here module. All get you to the same place. And you'll see a website that looks like this. And we can do all sorts of stuff on this website. Right, in fact, we'll be using this for, I think, all of our coding projects with the potential exception of our database project when we get toward the end there. So we'll be using this for all of our coding and web development projects going forward. But we'll go ahead and log in. I'm going to click log in here. It'll give me the ability to log into my account here. I recommend creating a new account with your CCC student email and, of course, a new password, right? Don't want to use our same password for everything. So let me just log in here. And once you log in, you'll see something like this. And obviously it won't, always say Replit Game Jam. There is a game jam though coming up where they'll, you build a game in 7 days and win prizes if you build a good game. But that's neither here nor there right now. One of the things that we'll want to do from here is we'll want to create a new REPL. And there are all sorts of options for us to be able to do that. Now, we see like the Create tab here. And I've got some languages here. You at first won't have those languages. I have them here because I code in them all the time. So they're like my favorite languages that are here. But you see this plus sign here. We can click that plus sign to create a new one. We can go up here to the upper right-hand corner and click that plus sign to create a new one. Or we can click this bright blue button right here, which it might be collapsed like that. We'll just click the hamburger menu to expand it there. And we can click that button there to create a new REPL. And that'll get us the dialog to create a new programming environment. So I'm going to click that, create REPL, and we'll get something that looks like this here. Right? Like if we see here, like I have favorites, because again, these are the ones that I'm coding in all the time. But as you can see here, I'm just going to kind of scroll down the list. There are tons of different programming languages that you can use or figure out or play with here. Right, like we can see we have PHP here. We have all sorts of JavaScript stuff here. All sorts of different programming languages and different libraries and different things here that you can play with and tinker with and, learn. Right, like that's a big thing for using an online IDE like this is learning. So I'm just going to start in my search templates box here. I'm just going to start typing in Python. And you'll get several things here, right? Like you'll get Python with turtle, which is neat, but it's not what we need. There's a Discord bot starter here in Python. The thing that you want, though, is just the one that just says Python, just straight up Python. So we're going to click that. Over here in the title, it will give you just like a randomized name. Here you can change that and make it whatever you want. I'm going to call this, let's say, CTI 110 401 Fa21 demo or test. Let's call it that. And we'll create that. And then we get an environment that looks like this, right? We have three sort of sections to our screen here. All the way over here on the left-hand side, we have our file pane, which is where we'd put files or we'd create new files, right? For our purposes here, we don't need to worry about that. In the middle here, that's where we write our code. And on the right here, this is our console. This is where we'll see our output from our code. And for all of you, when you get ready to submit your assignments, the way you'll do it is up here at the top. We have this URL. This URL is unique for you, and it's unique for this environment. So you just take that, highlight it, copy it, and that's what you'll put into the Blackboard submission there, is that. So now that we know how to create this Python environment, we know how to do all this, let's figure out a few lines of code for what all we're going to be doing. Right, so let's start out by looking at the shebang. Right, the shebang isn't technically a line of code, right? It's more of a single line script that is telling our computer to do something. Every Python program that we write should start off with this shebang line. The term shebang is a portmanteau or smashing together, right? Where we take two words and smash them together. The fancy term for that is a portmanteau of the words hash, which we have the hashtag symbol there, and the term bang, which is an exclamation point. Right? In programming, we call another way that we refer to an exclamation point is as a bang. And like you might even like seen old like cartoons where like, they have the gun that has the flag come out of it, and on the flag there's like exclamation points. Right? Maybe like 3 exclamation points or something like that. And that's representative of bang. Right? Like that's where that comes from. or that's why they do that, right? Because an exclamation point is also called a bang. So when we take our hashtag and our exclamation point and put it together, we call it a shebang. You might also hear it termed as a hash bang, but generally shebang. The shebang line in any script determines the script's ability to be executed like a standalone executable, right? So if I have Python installed on my computer and I have this .py file that I have saved that has my shebang at the top of it, that means I can go double click it, and when it starts to read what's in that file, it's just going to run it because I have that shebang in there. So it's best practice kind of for what we're doing at this point. You know, it creates an executable without, you know, us having to go in there and do anything special with it. Right? So we want to put this shebang in all of our programs. And we see the example of our shebang here. Right, we see here hash bang or shebang, that hashtag and that exclamation point, /USR/BIN/ENV, Python 3. And as we kind of look at this, one of the things that we want to remember, right, is that we said programming requires precision. Notice the direction of the slashes. Notice that this is all lowercase. I want to see this line in your programs. So let's go ahead and add this line to that code editor that we have pulled up over here. So here's our REPL. We'll zoom in so you can see this all a little bit closer. And I'm going to type hash bang /USR/BIN/ENV Python 3. Just like that. So the thing here, you know, just take this in, notice it, you know, write it down, keep it in your mind. You'll need that. So that's the way we're going to start out every Python program that we write. And so from here as well, the first program that you typically write in any programming language is called a hello world. So let's examine a hello world in Python. And normally, like, this is your programming assignment in a lot of programming classes. Your very first assignment is going to be to write a hello world. That's too easy. It's too easy in Python. Right? I mean, it'd basically just be like getting a free 100. If I gave you a hello world as an assignment here. It's too easy. So let's go ahead, get our feet wet, and do a hello world here. Right, and you'll see just how easy this is. So in order to do a hello world, remember back earlier we talked about the different things that we needed for a programming language. We need an input, we need an output, we need conditionals, we need repetition, you know, all that stuff and we need the ability to do mathematical computations, right? And so what we need to be able to do here is do one of those things, which is the output. We need to be able to have the output for our program. And so in Python, we do that using a print function. So we type in the word print and follow that up with parentheses. Now, one of the great things that you see here is that since we're using this integrated development environment, this IDE, when I type the word print, print is a reserved word in Python. You can see it comes up as a different color there. When I type the opening parenthesis after the word print, it goes ahead and closes the parenthesis for me. Now, when we see a structure like this, when we see a reserved keyword like print next to a couple of parentheses like this, this is indicative that this is a built-in function in our programming language, right? Seeing this structure here. We can create our own functions, But this is a built-in function that's already in one of those predetermined modules, like we talked about earlier. And a function, as you might remember from your Hour of Code lab, is just a set of instructions that do one thing that we can take and all group together. Right, and so in here, inside of quotes, I'm going to type hello world, just like that. And that's the hello world. Right, that's why I don't have this as an assignment. It's way too easy. Now, we can talk about a few things here in relation to all of this. Yes? One of the first things to point out here are these quotes. These quotes here make whatever is in between these quotes a string. And a string is one of our data types. A string is just the characters that we see here. And these characters can be letters, they can be numbers, they can be symbols. But this is where we get into one of those issues that we've kind of been talking about all along. Right? Because when we have a string, those string characters, like our H here, are what we'd see like on our ASCII chart that we've looked at previously. Right? When our computer is interpreting this string, it's referencing those letters against that ASCII chart and getting those codes for those letters from there. Which means something which is also valid is to put a numerical symbol in between quotes. Now, at this point, this numerical symbol is no longer the number 2. It's a symbol that represents a 2 on the screen. Right? Like if we go back to those ASCII charts and look at the value, right, and break it down, this is a totally different thing than this. And one of the key important things that we need to remember as we're approaching this is that if we have numbers that are in a string, they're not numbers. They're characters. Characters that are on the ASCII chart. So we can't do math with them because they're not numbers. Right? When we're using numbers, we don't put them in quotes because putting them in quotes stringifies them. So if we want to be able to do math with them, we either have to have them without quotes or we'll need to be able to typecast them, which we'll look at as well, which means change their type. So let's look at doing something with numbers here. Like our arithmetic operators. So after we get through our hello world, which our hello world was super simple and we just did it right there, the next step is to do arithmetic. So we have these mathematic operators, which are our special symbols that represent those basic mathematical computations. That's 2 of those 5 things that we looked at earlier, right? We know our output here because we just learned our print statement. And now we're looking at the mathematical operators that we talked about. So after this, we only need to discuss input, loops, and conditions. Right, and so we see these basic mathematic operators here, plus, minus, multiplication, division. Those are easy enough. Let's just go check these out in our programming language here. Let's just write a few print statements here that examine all of these. Right, so when we write a print statement, again here, since we're doing mathematical calculations, we don't put things in quotes. We just type them in. So if I said like 2 plus 2, no quotes there. I'm going to click run here, and I'm going to get 4 there on that second line, which is exactly what we should expect. And we can go through and we can do all of those basic operators. There's subtract, there's multiply, and there's divide, right? And we can run that and we can see the evaluation of all of these mathematical operations. 4, 4, 10, 1.5. Now, what if we tried to put a string in there? Right, like let's say we said, okay, let's do print 8 as a string divided by 2. Right, so we said that 8 as a string is no longer an 8. It's a representative character based on the value on that ASCII chart. So it's not a number anymore. So we can't do a mathematical operation with it. So if we tried to run that now, boom, big error there. And one of the important things for us to look at here when we get these errors, remember we talked about last module, we're probably going to get errors. We don't need to be discouraged when we get errors because we need to get comfortable with not knowing. So the bigger thing here is that what we want to do is we want to start to be able to read these errors and learn from them. Right? And so we can see here that in my file main.py, which is the file that we're working in, right? Like if I go over here and look, I see it's called main.py. On line 8, that's line 8. And it tells me print my string 8 divided by 2. That's my issue. Unsupported operand types for string and integer. Right? That means we can't use that operator to divide an integer from a string. Like that's not math, right? Like that's like saying tree divided by 7. It doesn't work. What does that mean? So we can't do that. One of the things we can do, however, is we can use multiple of these together, right? So we could say 6 times 8 minus 4, and that's going to evaluate to our results there using Pemdas Rules, which here 44. Right, if you need a refresher on PEMDAS, right, PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Remember that we do multiplication and division on the same level, addition and subtraction on the same level. So if we have multiplication and division and all in one problem, we go from left to right. Addition and subtraction, all in one problem, we go from left to right. But we do these otherwise in this order. Right, so essentially what my computer here is interpreting this 6 times 8 minus 4 at as is 6 times 8, which gives us 48 minus 4, and then 48 minus 4, which gives us 44, which is the result that we got up here in our window. But what if we didn't want to have our equation here evaluated like this? Because if we evaluated this equation in a different order, we have a much different problem, and that's what our parentheses are for. And so when we're performing mathematic computations in programming, what I like to do is I like to make sure that I'm using my parentheses and putting my parentheses in the right place just to make my calculations specific. Because 6 times 8 minus 4 is a lot different than 6 times 8 minus 4. Right? In that latter case, since we added those different parentheses in there, we've changed the order of operations. Now we're doing that subtraction first because it's inside of those parentheses. So 8 minus 4 then becomes 4. And we do 6 times 4, which is 24. Which is a much different answer than 44. So when we're talking about something in relation to precision, which we're talking about like programming, we want to use these parentheses here. And we want to make sure that we're doing it right. Now let's talk about some other arithmetic operators, some more advanced arithmetic operators. These are exponential notation, which is asterisk, asterisk, like two asterisks. Right, and so this is for us to use exponents, right? Like if we look at PEMDAS, we see PE, E for exponent, right? So we're raising something to the power of something else. If we want to do something squared, we can do that. For example, and then we have our modulo here. And our modulo is a pretty interesting case, right? Because what our modulo does is our modulo finds the remainder. Right? So our modulo is for the remainder. So you might be used to seeing something like 4 divided by 2. So 4 divided by 2, that's a pretty easy problem. Right? We know 2 times 2 is 4, so 4 divided by 2, 2 goes into 4 2 times, so we end up with 2 as our result. However, for modulo 2, and we represent modulo by using the percent symbol, for modulo 2 equals 0. Because again, modulo is the remainder after our division problem is calculated. Since 2 goes into 4 evenly, there's no remainder, so the result there is 0. If I said something like 5 modulo 3, right? Like if we had that as 5 divided by 3, it's something like like 1.6 or whatever, or 1.4, something like that, right? I'm not, we talked about it last week. We need to know language. But 5 modulo 3 is 2. Yes, 3 goes in evenly one time, which gives you a remainder of 2. So one of the things that's very useful to us to use our modulo for is to figure out whether a number is even or odd. Because we can use this in conjunction with a conditional, right? And we can say if some number modulo 2 is 0, then it is even. Because 2 goes in there evenly. Otherwise, if it's not true, it is odd. Because if it has anything other than a 0 in there, that means it doesn't go, 2 does not go into that bigger number evenly. So you have some kind of remainder, so it's odd. Right, so that's incredibly useful. Let's just see an example of both of those in our script here. So I can print out 3 asterisk asterisk 3. So that's 3 to the third power, right? So that's 3 times 3 is 9, times 3 is 27. So we should expect that to evaluate to a 27. And we can print 100 modulo 10. If that were a regular division problem, right, that would resolve to 10. But since 10 goes into 100 evenly, it is 0. Right, so if we run all these now, there we see 27, there we see 0. Pretty cool. And we're definitely going to run over a few minutes today, but that's just going to be what it is. If you're watching live and you need to cut out, that's just fine. Just make sure to pick up from here on the recording. All of these things that we've seen so far, though, are values. Our value works with all of these programs, so we see things like 2 and 42.0 and hello world, right? All of these things that we can work with in a program, whether they are a string or something else that we can do math with, are called values. Now, these values all have a type, right? We mentioned these data types earlier. Like a 2 without a decimal number, like just that plain 2 is an integer, right? An integer is a whole number. Now we add a 0.0 onto that. For example, like our second example here was 42.0. Now it's a floating point number. And then we've already talked about our hello world in quotes, which is a string. And just as a little aside here, we call it a string because the letters are strung together. Now we have this built-in function in Python called our type function. And this type function will let you know what type of data something is. So that's the big thing that's going to clear up for us that mystery of numbers inside of strings, right? So if we write our type function and we put 2 in there, right? We would do it something like this, right? We have our print function here, and we can see print with the parentheses. We see type here with the parentheses, and then inside of that we have some kind of data value. We run that, we get class string here, class str. So we know that even though that's a number 2, because it has quotes around it, it becomes a string, which is super important for us to remember. Now, before we look at our inputs, and I think that's where I'd probably like for us to stop today, is with our inputs. I'll do everything else in another video for you. I'd like to talk about variables and inputs to wrap things up today, because we're going long. Right? But it's a big, important thing to talk about a variable, and we'll kind of breeze through this talking about a variable, because a lot of the stuff that we have here about a variable, we talked about in the last module. So this is just kind of refreshing ourselves. Right? When we're talking about a variable, we're essentially talking about a container. We got a little Tupperware container here, right? It's something that we can put stuff into and later on take stuff out of it. So we can create a name that we put onto this container, something like, whatever we want it to be really, tree, hat, whatever. And then we can assign it a value by creating, adding an equal sign, putting some value to it. And this creates a symbolic relationship between the variable name and the data that we put in it. Now, Python, again, is weak typed. It's dynamically typed. So we don't have to declare the variable type that we go along with the variable. It just understands. Now, we do have some rules, right? We said we can essentially name variables whatever we want to name them. But we do have a few rules here. Variables cannot be a reserved keyword. Right? Things like print and type, things like that we've already seen, that Python uses to do other calculations and stuff. We can't use those. Variables cannot start with a number, and I get this on occasion. People ask me, well, why? Why can't variables start with a number? What's the big deal there? Right? And variables can't start with a number because when my interpreter is going through line by line and reading everything that's going on, when it hits a number, it thinks, oh boy, I'm about to do math. But then it sees some letters right after that number. And it gets confused because it's like, I can't do math with these. I thought this is a number. I thought I was going to do math. Right? Because it hasn't got to that variable assignment part yet. So it doesn't know what you're doing with it. So you can't start variables with a number. You can't use a reserved keyword. And remember that our variable names are specific. So if we start with an uppercase letter in our variable at the top, whenever we reference that variable later on, we have to use an uppercase variable again. And now when we look at variable assignment, we assign a variable using an equal symbol. So, when we kind of think about it in another way, like a common way to represent variables on paper is to write the name with an arrow pointing to its value. So we say here x equals 27. So we're creating this variable container. Right, we're creating this variable container. We're putting a label on it of x. And we take and we put a value inside of here. That is 27. So then whenever we refer to x later on in our program, we're referring to the value that's inside of that x container. We've created that symbolic relationship. So until we give it a different value, it's going to be 27. Right? Same thing with our hello world here. We have the term hello world. And we set that equal to a string of hello world. And so whenever we use this part later on in our program, it has a symbolic relationship to the value that's put inside of it. So let's just see that in action. And I'm going to give you all the link to this file here. Right? So I'm going to try to keep as much of it intact as possible. What I'm going to do here is I'm going to comment out everything that we've done so far, just so it doesn't go through printing it all over here again. So I'm going to take and type at the top of the code that I want to comment out, I'm going to type quote, quote, quote. So 3 quotes. It'll add a 4th one. You just want to get rid of that 4th one. And then I'm going to go to the bottom of the code that I want to quote out and type in quote, quote, quote again. And that defines a block of a quote. Or a block of a comment, rather. That defines a comment block. And so when we create a comment block like that, what we're essentially doing is we're telling our interpreter, ignore all this. This is just for information purposes, or this doesn't matter right now. We don't need to use this. Ignore all of it. So let's create a variable. And one of the things that I like to do is I like to create a variable that is, I like to kind of demonstrate stuff in a manner that is useful, right? So let's create an area of a square program really quickly, right? We'll create this area of a square program. We will assign some values to some variables, and we'll assign some calculations to a variable, right? So let's start by just assigning a value to a variable. Let's call this side underscore length. So this is side length, right? And we are just going to assign it just some number. For right now, we're going to make it 5. In a few minutes, we'll update this program. We'll make it a little bit more functional by giving it an input to use. So we're going to have side length, and we're going to call it 5. Right, so we know then that since we're doing a square here, we know that we can take and we can multiply this, so we can put it, we can just do that and have the area of our square. Right, and that would work. But we don't want to do that for multiple reasons. And it'll become more clear when we add our input function here as to why we wouldn't want to do that. But one of the things that we want to obey here are our composition rules. Right? When we write a program, we kind of want to break it into parts. So as we write a part, and each part we know functions, then we don't have to mess with that part again. And so we can take these already functioning parts and we can incorporate them into new parts. And that helps make our lives a whole lot easier. So now that I have this side length 5 here, I can print out to my console, print side underscore length, right? So I put in that label for that container there. It's going to go back, it's going to reference this. It's going to grab it. It's going to put it here, 5. So we know it works. Right? We did that correctly. So now I can take this and write an area variable and set that equal to side length squared. So now when it evaluates my area variable, it'll take the value that I have in side length and square it. And then we can put out our area. Like so. 25. So this is a super simple program just to get us started here. I mean, we could also, like, I like to do area of a circle for this as well, right? In fact, let's do that really quickly. I'm going to take and I'm going to move this block quote area down here. Right, just so you could all get a different example. Let's think through our algorithm before we do this. Yes, so our area of a circle is pi times radius squared is our area of our circle. So for our program here, we need to define pi as a variable. We need to get our radius as a variable. We need to square our radius. And then we need to take and multiply pi by the result. So, like, again, we could just do this in one, right? We could write one line that does this. But in order to make our program more flexible, we need to obey our composition rules. So we'll start out by defining pi. And since pi is a constant, typically in Python, we denote a constant, something that's not changing, by using all caps for its name. So pi equals 3.14 for our purposes here. We'll give just some random arbitrary value to radius. We'll call radius r. And we'll give it like 4 for right now. R squared. We could set that equal to R2. R squared, R to the raised to the exponent of 2, and circle area equals pi times R squared. So what's the benefit of doing it this way instead of doing it all in one line? Right, because technically we could do it all in our print statement, right? Like we could do it all as print 3.14 times 4 raised to the exponent of 2. Right, and this is an okay example because, like, in this instance, right, it's going to work because our Pemdas rules apply here. So we can say, well, 4 times, we can see here we've got our exponent here. It's going to do that before it does this. So it's going to raise 4 squared. But when we get into more complex algorithms, and we're doing bigger mathematical equations where you have parentheses nested inside of parentheses nested inside of parentheses, and you get those layers upon layers where things start to become confusing, not only does breaking it down this way make it easier for us to understand, it also makes it easier for us to find errors if we make them. We can go and we can kind of go through all of our different levels. We could even do something that we call incremental testing and test at various points. So like I might print out r squared here just to make sure that it gives me the result of 4 squared before I continue with anything else. That way I know r squared works. And so here I can print out circle area and get our result. 50.24. Now, this is all well and good, right? But every time I want to do something with this, like if I wanted to calculate the area of a different circle, I'd have to go back in here and rewrite the program. In this case, it's pretty easy, but in other cases, it might be much more difficult. And you wouldn't necessarily expect your user to have a bunch of programming experience so they can know how to rewrite every program you've written. So what we want to do here is we want to allow the ability for inputs. And for inputs, we get input from our user by passing the results of an input function to a variable. And so we see an example here. Input, in between those parentheses there, we put a string that is a message for our user, right? We always want to prompt our user with some kind of message there, because otherwise they have no idea what they're supposed to be typing in, or that they're even supposed to be typing something in. And so our user can then type something into the console and hit enter, and whatever value they type into the console is taken and stored in the variable name, in that variable container that we create here. So an important thing to note is that everything that's passed from an input function from the console to a variable is passed as a string data type, which again means if you want a number to come out of that, it's not going to be 1 immediately. Right? If somebody puts in a 2, that's not a 2. That is a visual representation of the character 2. So we need to typecast it. And when we typecast in programming, that just means taking something of one type and converting it to another type. And so all we would have to do here is take our input and wrap it in an int function for this to work. So let's take our program that we're writing here. Let's add this little bit to it. Right, so we'll put our input function here, and we'll say input, and parentheses there. Remember, that's a pre-built function. It changed the color. We put the parentheses after it. We can see it looks just like print. And in between here, we're going to write our message to our user. Enter the radius. Colon space. Right? We put that space at the end because whatever we put in our string here is going to be reflected in our output. Right? So we want to make sure that, if we want a space between the end of this message and what our user is going to be typing in, we want to put that space here. Now, before we do this, let me just take this out really quickly just so you can get the understanding of what's going on here. Let me cut that. Right? So if we don't put a message in here, what happens? Right? If I run that, I get the console that you see here, right? We just see that little white rectangle there. Like, I can type things in there, but I don't know what I should be typing. I don't know that I can be typing anything in there, and I don't know what I should be typing in there, which is why we always want to include a message. So now we have this set up to have a message. We haven't done our typecasting yet. So let's just see what happens, right? If we want to enter the radius of, say, 6 and hit enter here, it's going to error out. Let's just get ready for it. There's our error, right? And again, we can read that error. Main.py, main.py, line 22, line 22, unsupported operand for exponent, string, and integer. So again, it brought that string in as a 6 because that string came in from an input function. So what I can do here is I can do two things. I can either take and create a new variable, call it like rint, and set that equal to the integer of r. So that typecasts that value that's currently in r, changes it from the string to the number, right? So instead of the character representing a 6, it's just a 6. And puts it into a new variable, which we could include here. Or we could just wrap this whole thing in it. And in this case, it's going to be either one that you're more comfortable with. You know, remember that we discussed before that one of the big things is, you know, there's 100 different ways to do something as we program. Trying to figure out how you're going to solve your problem is the thing here. So now that we have that typecast to an integer, whenever we enter a number here like 6, it's going to take that 6 in. It's going to take it in as a character, but then it's going to see, oh, I need to typecast this into an integer. So it's going to take that character 6, just make it into the number 6, and use that to do the math. And we get 113.04. And now instead of editing the program, we just run our program again. We enter a different number, and we get a different result. Right, so we've gone over an hour and 15 minutes now. So that's way longer than I want to go. So we're going to stop here. Right, we've got a ton more to cover. Right, so I'll put it out in other videos throughout the week. I'll put out another video, say around Wednesday. That'll be the second half of this lecture, and then I'll put out another video for our live stream next Monday that's pre-recorded since it's fall break, that does a complete program from beginning to end. And that'll be, you know, that'll cover all of our material. Right? So that's all that I'm going to do for today. I'm going to hang out in the chat for just a few minutes, just to field any questions if anybody's here with me live. Thank you for watching, and we'll see you next time.